Welcome to another episode and video on my Raspberry Pi 1 connected to a serial cable via the RaspberryPi Plus add-on board. Then network cable for VNC, virtual network computing, as well as band cable via the GPIO to a breadboard with electronics, and the Raspberry Cam, which I am not using right now, but I might again. It's running Raspbian Linux, which is not the newest version, but it's still able to update. And as said, it is connected to this breadboard with electronics. Now on this breadboard you see two chips. This one is an analog to digital converter running the SPI protocol, serial peripheral interface, but currently I am focusing on this chip, which is I2C using the MCP 23008 chip, and via these two probes connected to oscilloscope, as well as these wires to the GPIO, I measure the clock and data. Last time I managed to get two programs running, activating also these LEDs, and it turned out that some problems are caused by things that I didn't exactly thought they would happen. First of all, I need to do sudo to access or to run both, to run either of the programs and access via the GPIO, but also it turned out that I need to sometimes power on and power off the chip to get it running. So right now I will start, or try to start, the demo first, which is the running LED. So running means on off, on off, on off, on off, etc., and then vice versa. So I will start it right now, and then it helps when I'm in the correct directory. And to my surprise, not all LEDs are responding. So whatever that causes, I don't know, but that's a bit weird. So let's interrupt this and see what wiring pi does. Exactly the same. So there is something in the hardware that is not entirely as expected. No wires are missing, except, oh yeah, there are two wires missing. That is not good. I need to fix this. And when fixed, because the LEDs need to be completely wired, and these are wired through and through. So if one wire is broken, is not connected, these ones won't work. Ouch. So I have to fix that. Right, so what it comes down to is that in this schematics with the GPIO, the MCP 2020 23008, yeah, an array of LEDs and resistors and accompanying LEDs connected to mains, to ground. And then the point is that an LED only works when it is connected to ground. So that is one of the problems. Fortunately, I did not have to cycle power like last time. But something I also found out is that apparently the connecting of the probes is of influence. So right now everything works, and it took wires from this side, which is this side, and it took wiring from this side to get things working again. So this is, hold on, that is this one, the demo, which is going up and down, and the wiring pi is it visible? It is visible. Yeah. So oscilloscope is working, everything. This is working. So right now I'm quite happy that all wires are nicely connected, that the chip works, etc. So where to go from here? Well, as with all my experiments, expanding. The question is only how to expand. And yes, that is the most important question. How can I expand this? Originally the wiring pi had a button, but usually you have power, then a data signal and something else. And if I have a button, how would I do that? Because right now in this program that I didn't write, it just does something, and it would be nice. Oh, that is of course very nice. If I am using my own program, if I can add something, for instance a button that that it would reverse the direction. So right now it goes up and down, and when I have a button, any button, it would go the other way. Can that be done just like that? Or do I need a special I2C button? I'm not quite sure. Didn't try. Do I have to change the algorithm? Yes, of course I do. Because this is one way, and after a delay of let's say 300, let's say that is a millisecond, it goes the other way. So it would have to wait for the button. How would it have to wait for the button? And that's a nice one. Because addressing the LEDs is a matter of going forward, addressing it. This is addressing. This line is addressing everything. It writes. Then I have a delay, which I'm going to replace, and then it does the other thing. So it would be like, while everything keep doing it, that won't change, and then if a button is pressed. So for that I need one of the other channels, which is still free, which I read, and then I'm not talking about one of the channels here, I'm talking one of the channels on the RPI, on the GPIO. Yeah, RPI GPIO. So that would be a nice thing to do. Press the button and reverse it. So let's interrupt this one and say, okay, if the button is not pressed, but I would need to know which one of the GPIO pins to use. So let's find out. And of course, it is never as simple. First of all, I'm choosing C. Second, what I thought to remember was, yeah, I had controlled LEDs, but that is in C++, not in C. I'm not using Python right now, I'm using C. So here goes a nice website with GPIO code examples using various C libraries. Dynamic direct register access, I'm skipping it. Wiring Pi, yeah, I'm using that, but not in the code that I wrote, not in the demo that I'm using. Well, yeah, you may be correct. This isn't the program that I wrote myself, but I heavily adapted it. This is wiring Pi and I just adapted it a little bit. So I am for now using this one, and it's not using any of those yet. Anyway, for now I skip wiring Pi, but I will get back to it. System, file system, sysfs, skipping it. Then, interesting, the BCM2835 library must be done as root. Not a problem, but I'm skipping it because I come across the PI GPIO, the Pi GPIO library. And is that something new? Not really, because look here, Pi GPIO right here. So I already have it to use the piscope program, which implies I already have it. Now the only thing is, where do I have it? Well, right here. And that has to be in capitals then. Yes. And what I have to do, this is a demo. and here is the pigpio header file, and right here in this code I have to use it. So because other things take maybe too long time for now, I'm using the pigpio for my adventure. And let's see how to do that. First of all, I have to go to line 13. And now one of the things is that I have to, oops, that doesn't go right. I have to give the exact path. Now here I am originally in MCP 23008, so I have to say okay, and now I wonder if this is going to work. So what does this say? This says home directory, downloads directory, and yes, it is downloads. Then into the pigpio directory, and in there is the pigpio header file. And I do hope that this works, otherwise I will have to change the tilde into /home/pi. But let's see whatever happens with this. So I am going no. So I'm going here, and I'm going to check if this is going to work step by step. So or do I do make all? Let's do make all. That was this one. Alright. Fatal. No such file directory. Okay. That is what I wanted to know. So I will change this into /home, home/pi. This should do the job. It does. Alright. So this means that I am going where now? Yeah, this is better. Oh, this needs an explanation. In Python, you have indents as well, being spaces or tabs, and you have to use either one or the other. If you start using spaces and continue using tabs, it doesn't accept it as the same spacing, as the same kind of indents. In C, no problem. Also in Python, like here, if you have a while loop, or in C, if you have a while loop, you start it with this equivalent bracket and you close it, and in that way you just do it. It doesn't even matter if you put all the text right here, the bracket says it's opening. In Python, you have not such thing like this bracket, and the indentation says it's a structured text, and then either spaces or tabs. Anyway, according to the info in the browser, I have now to use, and I've chosen, also quite important, right, now I have to use, no, where do I have it? Oh, come on. No. Did I really lose that page? No, here. So what I've used is 3 volt 3 ground, and this one is already in use, so I've chosen to use 12, which is easy to distinguish. Back here, or more appropriately here. Yeah. Here are some other languages: Python, Perl, Ruby. No experience with Ruby yet. C#, more appropriately for another operating system, not so much for Linux. Anyway, I have to set this for pi input. Oh, this not a hyphen, this is an underscore. And that's for an input, and here I should be using GPO read something. So and 12, something like this. And I haven't even wired it yet, so I need to do some configuration with some button as well as a wire. So let's get to that. Yeah, nice. So having ideas is very nice, but execution is a very different thing. Alright, so now the situation is as follows. A button added, and it's not wired to this one. Let me show you in schematics. So this is the new situation with what I was looking at wondered me, because I had forgotten to renumber all the resistors here. I had 6 resistors, 3, so now everything is as should be. Resistor 1 through 8, well, I have to change this one as well, but comes later. Now a make button, wired to voltage 3.3 volts. Then on the other side of the switch, which I have to still rename, done, GPO pin 12 and a wire via resistor to ground. That is the new situation. Does it work? I don't know yet. It's wired? Yes, it is. Will this work? Well, I can only check for this by means of right now, say if yeah, how do you call that one? If a pin, because I have there a set mode to 12. How do I know if it is working? Do I read it? Anything at all? Good question. I think that I have to make it like if GPIO write 12 is 1. I think that's the better way to do it. So this one goes. Then if GPIO read 12, double bracket here, then insert is 1, lose the semicolon, bracket, oops, not quite correct, and another one, then I hope this will work, and then slash n for new line. Did I do this correctly? No, I did not. I haven't. Now it is correct. So so one pair of brackets around the 12, and then a pair of brackets around the whole instruction. That should be working. So if GPIO read 12 is 1, then do that. Alright, written, make all. Only find the reference. Oh dear. That would make sense if I say -L pi GPIO, because this looks way too familiar, like the wiring pi stuff. So let's see if this works. If not, I'll have to change the makefile. Ha! Alright. I didn't expect this to happen. So this is kind of the same thing like I'm doing here. And let's go to 1. I have here the inclusion of wiring pi. And yet I have to include this when I do when I compile the whole thing. I have to include the library wiring pi. Now I am using this one, and yes, it did take right here, it did take the complete path, but now with compiling it seems like I have to use this anyway. Yeah, and I'm out of time. I have to continue next time. Let's see this one. Okay, this is the whole stuff for the demo. And where do I have inclusions? Oh, right here. Here are all the header files, which are right now quite alright. But I will have to see next time. So I will add now a comment telling pigpio question mark. Yeah. So, new interesting adventure. So, the goodbye segment again. What did I do? Well, apart from fixing the wiring and using all demos, all the sudos commands to get demo and RaspberryPi version done, I've now added a brown wire from the button to the plus, then a resistor to connect the button to the ground, and a wire from the button to pin 12. And as you could see, I have to change something with the compilation in order to get it working. I didn't expect that, but it has to be. In the meantime, thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up. Leave a comment. Much appreciated. You can also follow me on Twitter. Please retweet, like and leave a comment. You can also follow me on Instagram. Please like and leave a comment. Please show your support by donating a little bit of money. More information on my website and at the beginning of this video. You can also choose to become a patron and have your name mentioned as a supporter, either on my website or on my website and with my videos, depending on the pledge you make. And this is, of course, going to be continued. Thank you for watching, and bye bye.